Hello viewers, in today's class we are going to discuss one important definite integral in which signum function is involved, right? So here we have to find the value of the integral from -1 to 2 and e raised to x signum of x dx, right? So let us start. So here we have to first make use of the definition of signum function, and we know that signum function is defined as signum of x is equal to +1 whenever x is greater than 0, and signum of x is equal to 0 whenever x is equal to 0, right? And signum of x is equal to -1 whenever x is less than 0, right? So this is the definition of signum function, right? Now here we have to integrate this function from -1 to 2, and if we take the real number line, then we see that here we have the point 0, and here we have -1, and 2 lies somewhere here, right? Okay, so now here we have plotted the points 0, -1 and 2, right? And now this integral I can be written as a sum of two integrals, that is I1 and I2, right? So I1 is from -1 to 0, right? So here we'll break the limit. X equal to 0 is the point where we have to break the integral, right? So we have -1 to 0, and here we have e raised to x signum of x dx, and I2 is from 0 to 2, right? Okay, so here we have e raised to x signum of x dx. Okay, so now if we closely look at this real number line, then we see that when x belongs to 0 to infinity, then x is greater than 0, right? So signum of x is +1 whenever x is greater than 0. It means x lies in the interval 0 to infinity. And similarly, when x belongs to minus infinity to 0, then x is less than 0, and here signum of x takes the value -1, right? And now we see that in this portion x is greater than 0, and in this portion x is less than 0, right? So now here we have the integral from -1 to 0, and we see that from -1 to 0 x is less than 0. So therefore signum of x will take the value -1. So we have -1 to 0 e raised to x, and for signum of x we have -1, right? Okay, now in the second integral, which is from 0 to 2, we see that x is greater than 0. So therefore signum of x will take the value +1, right? So we have e raised to x, and here we have +1 and dx, right? So now we have these two integrals, and it is quite easy to solve these two integrals, right? So here we have -1 to 0 e raised to x dx, and then we have 0 to 2 e raised to x dx, and the integral of e raised to x is e raised to x. So we have minus e raised to x, and the limits are from -1 to 0, and here we have the integral e raised to x, and the limits are from 0 to 2, right? Now we have to simply substitute the limits, and we'll take the difference. So we have e raised to 0 minus e raised to -1, and here we have e square minus e raised to 0, right? And e raised to 0 is 1, and here we have 1 over e, and here we have e square, and here we have e raised to 0 is 1. So now we can write it minus 1 plus 1 over e plus e square minus 1, right? And therefore I is equal to e square plus 1 over e and minus 2, right? So viewers, the value of the given integral is e square plus 1 over e minus 2. So this is how we solve this problem.